All right, in this video we are going to review how to solve some of these word problems that we've encountered in Chapter 5 using synthetic division. The first one says the expression v of x equals x cubed minus 13x plus 12 represents the volume of a rectangular safe in cubic feet. The length of the safe is x plus 4. What linear expressions with integer coefficients could represent the other dimensions of the safe? Assume that the height is greater than the width. All right, so if we think back to our geometry, we know volume equals length times width times height. So they've given me a volume and they've given me a length. Okay? So if I take volume and divide by length, what I will have left is the width times the height. So I'm going to use that idea to help me figure out what that product might be, and then I can factor it to find the two individual dimensions. So I'm going to take my volume, x cubed minus 13x plus 12, and I'm going to divide by x plus 4. Since I'm dividing by a linear expression, I can do this synthetically. So I'm going to put a negative 4 out front. My coefficients are 1 and then 0 because I'm missing the x cubes, negative 13 and 12. Using that synthetic process, we bring down our first 1, we multiply the negative 4 and the 1, which gets us negative 4, and then we add that column. And we keep repeating that. So negative 4 times negative 4 would be 16, adding would be 3. And negative 4 times negative 3 would be negative 12, adding gets me a 0. So since I have no remainder, it means that divided out nicely, which we should have expected since it was one of the dimensions that created the volume. And what I have left, this was the remainder, constant x and x squared. So the piece that I have left is an x squared minus 4x plus 3. And I can go ahead and factor that. X squared would split into x times x. The positive 3, I could use a negative 3 and a negative 1. Insides and outsides would then add up to that negative 4x. So I have my three dimensions. I know that the original one was x plus 4, and that was the length. And the other two now are the x minus 1 and the x minus 3. And the statement above said, assume that the height is greater. So subtracting 1 is going to give you a bigger number than subtracting 3. So this is going to be the height, and this would be the width. Okay? Our second example. It says a polynomial function f of x equals x to the fourth minus 5x cubed minus 28x squared plus 188x minus 240 is used to model a new roller coaster section. The loading zones will be placed at one of the zeros. What are the possible locations for the loading zones? So we are going to go through and look for possible zeros. All right. We have a quartic polynomial, so that means there are 4 possible zeros, which means there would be 4 sections or 4 places that we could list as our loading zone. So I'm going to start out making my list. Okay? I have factors of negative 240 divided by factors of 1. All right? Now, negative 240, there's a lot of factors of 240. So let's just start our list. 1 goes in there, 2 factors in there, 3 is a factor, 4, 5, 6, 8, 10. There's a whole bunch. All right? So let's go to the graphing calculator and see what it suggests. All right, so our first step, we need to type in our equation. So we had x to the fourth minus 5x cubed minus 28x squared plus 188x minus 240. Okay, I'm going to do a zoom 6 to just go back to a standard window. All right, and I see 4 pieces, or 4 x-intercepts, 4 places where it crosses the x-axis. On the far left, it looks like it's crossing at a negative 6, and then on the positive side, it looks like it's crossing at 2, 4, and 5. So let's go back and see if we can prove those work. All right, so our graph suggested -6, 2, 4, and 5. We're going to go through that synthetically. My coefficients are 1, -5, -28, 188, and -240. All right, we're going to start with our -6. I'm going to bring down the 1, multiply, and add. Multiply, and add. Multiply -6 with 38 is -228. When I add that, I end up with -40. And -6 times -40 is +240. So I have proved that that is one of the zeros. Okay? And then we're going to keep going. Our next zero is a 2. Bring down our 1. Multiply and add. Multiply and add. And multiply and add. One more time. We have a remainder of 0, so we proved that 2 is one of the ones that work. Trying the 4, we have 1 times 4, adding is -5, multiplying, and that one also works. And last, we are trying the 5. Bring down our 1. 5 times 1 is 5. Adding gets us no remainder. So we have proved that there are 4 zeros to that polynomial function: -6, 2, 4, and 5. All right, our third example says the product of 3 consecutive integers is 336. Write the polynomial equation in standard form and then solve synthetically to find the numbers. All right, so consecutive integers means 2 numbers that are right next to each other. So if x is my first number, the second number is just 1 higher than that, so x plus 1, and my third number would be 1 higher than that, so x plus 2. And the directions say that the product means we are multiplying, so the product of these. So if I take x times x plus 1 times x plus 2, I'm supposed to get 336. All right, I'm going to go ahead and simplify the left side here. I'm going to FOIL the x plus 1 and the x plus 2 to get x squared plus 3x plus 2. Then I'm going to distribute that x in. So I have x cubed plus 3x squared plus 2x. All right, it's equal to 336. And now I'm going to bring that 336 to the left side. So I have x cubed plus 3x squared plus 2x minus 336. And it now equals 0. I need to go to my graph and help narrow down what we think are possible zeros. 336 is another number that has a lot of different factors. So we're going to go to the graph and see what it suggests. All right, so our equation was x cubed plus 3x squared plus 2x minus 336. All right, looking at our graph. I only see one spot where it crosses, but that's fine. I'm just looking for that first number. So 1, 2, 3, 4, 5. Looks like this is crossing here at a 6. So let's go back and check to see if that truly works. So the graph suggested a 6. We're going to prove synthetically. My coefficients are 1, 3, 2, negative 336. And I want to see if 6 is actually a 0. So bring down our 1 and multiply, adding, multiplying, and adding. And 6 times 56 is 336. So I do get a remainder of 0. So that tells me that 6 is my first number. And they are supposed to be consecutive integers. So my numbers would have to be 6, 7, and 8. All right. Our next one is very similar, but this time it says we have 3 consecutive odd integers. We're still looking at the product of them. All right, so first number we'll say is x. Second number, if I want odd integers, picture numbers like 1, 3, 5, 7. All right, to go from 1 to 3, I have to add a 2. So whatever my x is, I have to add 2 to it to get to the next odd integer. And then my third number would be 2 higher than that one, which would be x plus 4. So again, we're taking the product of our 3 numbers, and this time our product is supposed to give us 1,287. So again, foiling our 2 binomials, we have x squared, insides and outsides give me 6x. Our last term is 8. Distributing our x, we have x cubed plus 6x squared plus 8x. I'm going to go ahead and bring that 1287 to the other side so that I can have it equaling 0. All right, again, we're going to go to our graphing calculator and see if we can find some zeros of that. All right, so our equation is x cubed plus 6x squared plus 8x minus 1,287. All right, let's go ahead and look at our graph. This time around, it looks like it is crossing the x-axis at 9. All right, so let's go back to our equation here. All right, so we think it's a 9. We're going to prove that. 1, 6, 8, negative 1287 are my coefficients. We're going to show that 9 should give us a 0 for remainder. Multiplying, adding. Multiplying 9 and 15, we get 135. Adding, we have 143. Multiplying 9 with 143 is 1287. So it did work. That means my first number is a 9. My second number is 2 higher than that, so 11. And my third number is 4 higher than the 9, so 13. And I do have 3 consecutive odd integers.